All right, let's talk about one of the most fundamental ingredients in any kitchen, flour. Today, we're going to dive deep and uncover the science that turns this simple powder into everything from an amazing, crusty loaf of bread to a super delicate cupcake.
You've probably been there, right? You follow a recipe to a T, but you swap out, say, bread flour for all-purpose, and you get a totally different result. It's a classic kitchen mystery, but don't worry. Today, we're going to solve it with a little bit of science.
So, here's our game plan. First, we're tackling that confusing flour aisle. Then we'll introduce the main character of our story, gluten. After that, we'll crack the code on the texture spectrum, uncover a few of flour's other secrets, and finally put it all together so you can achieve your perfect bake.
Okay, let's get right into it. I want you to picture yourself in the baking aisle. You're just staring at this wall of different flours. Bread, cake, all-purpose, whole wheat. They all kind of look the same, don't they? But scientifically, trust me, they are worlds apart.
And here's the first thing you really need to get. Flour isn't just ground-up grain. It's actually a scientific tool. Each and every type is specifically engineered to create a very specific texture, whether you're going for chewy or tender or that perfect flaky layers. Now, to really understand what makes flour tick, we have to talk about the secret ingredient. It's the one thing that's not even listed on the bag, but it controls absolutely everything. So let's meet our main character, gluten. So what is gluten really? Well, it's this incredible elastic network that forms when two proteins that are already in the flour get mixed with a liquid, like water. You should think of it like the scaffolding or the skeleton for your baked goods. It provides all the structure.
And how it forms is surprisingly simple. You start with these two proteins, gliadin and glutenin, and they're just dormant, hanging out in the dry flour. As soon as you add water, they kind of wake up. Then, when you mix or knead the dough, that physical work links them all together, creating that strong, stretchy gluten network.
So what does this gluten network actually do? Well, its elasticity is what allows dough to stretch and rise. It basically acts like millions of tiny little balloons that trap all the gas from yeast, and that's what makes bread so light and airy. And of course, that network is what gives you that satisfying structure and chew. And now for the big aha moment. This is where it all clicks into place. We're about to crack the code that connects the flour you use directly to the texture you get in the end. It really all comes down to one simple, elegant rule. The amount of protein in the flour dictates everything. More protein means you can form more gluten, and that gives you a chewier texture. Less protein, well, that means less gluten, which results in a softer, more tender bake. It's honestly that straightforward. And you can see that rule perfectly right here on this chart. Look at cake flour, way down on the low end with just 7 to 9% protein. All-purpose is your solid middle-of-the-road choice. And then way up at the top, you've got bread flour, which is a powerhouse, just packed with 12 to 14% protein, ready to build a really strong gluten network. This table breaks it down even more. You can see how cake flour's low protein gives you that soft, tender crumb. And bread flour's high protein is absolutely essential for a chewy pizza crust. But, hang on, look at whole wheat. It has the most protein of all, but the result is described as heavier. What's going on there? Well, it turns out there's another scientific secret at play.
Right, so just when you think you've got it all figured out, there's a twist. Because while protein is definitely the star of the show, it's not the only factor. Let's pull back the curtain on some of flour's other secrets.
First up, bleached versus unbleached. You see, bleached flour is treated with chemicals that don't just make it whiter, they also weaken those gluten-forming proteins. That makes it perfect for really tender bakes, like cakes. Unbleached flour, on the other hand, is just aged naturally, and that process actually helps it develop a stronger gluten potential, making it way better for chewy bread.
And remember that whole wheat flour mystery? Here's the solution. Whole grain flour contains the bran and the germ. Those little sharp bits of bran act like tiny knives, and they physically cut and shred the gluten strands while they're trying to form. That's what creates a denser bake. Refined flour is just the soft center of the wheat berry, so it lets those gluten strands grow long and strong.
And there are even more little factors at play. The way the flour is milled affects how much water it can absorb. Fat, like the butter in a pie crust, is a secret weapon. It coats the proteins to stop long gluten strands from forming, which is exactly how you get that perfect flakiness. Even something called starch damage plays a role. It's not a bad thing. It's actually food for yeast, and it helps you get that beautiful brown crust. So let's bring all of this awesome science together, because once you understand these principles, you're not just baking anymore. You're in control. you can master your recipes and get the exact result you want every single time. If there's one key takeaway from all this, it's this. The right flour gives you control. It controls how much gluten forms, how water gets absorbed, and how the final structure develops. It's all about deciding what you want to create, tender, chewy, flaky, or dense, and then choosing the right scientific tool for the job. So there you have it. You are now armed with the fundamental science of flour. The mystery of the baking aisle is officially solved. So the only real question left is, with all this new knowledge, what are you going to create?